2.9 is stoichiometry with solutions. We are looking at foundations in chemistry, part 2. And the outcome FC3, using stoichiometry to determine the relative amounts of substances consumed and produced in chemical reactions. We will learn how to determine the relative numbers of moles in a variety of chemical reactions using balanced chemical equations, how to relate the use of the mole to the coefficients in a balanced chemical equation, and compare this to the volume and concentration as measurable quantities, and how to perform stoichiometric calculations to predict the outcomes of chemical reactions using the correct units and significant digits. In any given solution, there are always the following two parts: the solvent, which is the most abundant substance, and the solute, which is the least abundant substance. These roles in a solution can be reversed if the composition of the solution changes. For example, in a 5% alcohol solution, water is the solvent and alcohol is the solute. However, if more alcohol is added to make 70% alcohol solution, then alcohol will be the solvent and water will be the solute. Remembering that aqueous solutions are solutions in which the solvent is water, and we deal with these frequently. When a solute like sodium chloride is introduced into a solvent like water, this solute will begin to dissolve. And the word concentration refers to how much solute is dissolved in the solution. You get the idea. Dissolving 2 cups of sugar in 1 liter of water will produce a more concentrated solution than dissolving 1 cup of sugar in 1 liter of water. And concentration can be measured in a variety of ways. By far the most useful is molarity. The molarity of a solution is calculated by taking the moles of the solute and dividing by the liters of solution. Remembering this from our conversions, molarity is moles of solute over liters of solution, and we write molarity as a big M, or moles over liter, and moles of solute is measured in moles, and liters of solution, make sure it has to be in liters, not milliliters. For example, suppose we had 1 mole of sucrose, which is about 342.3 grams, and proceeded to mix it into some water. It would dissolve and make sugar water. If we keep adding the water, dissolving and stirring until all the solid was gone, then we made sure that everything was well mixed and there was exactly 1 liter of solution, what would the molarity of the solution be? Remember that molarity is moles over liter. We have 1 mole of sugar over 1 liter of water. Our molarity is just 1.00 molar. 1.00 big M. Again, so molarity, 1 mole over 1 liter. The answer is 1.00 mole per liter. Notice that both the units of mole and liter remain, neither cancels, and we often replace moles per liter with that capital M. So if you write the answer 1.00 big M or molar for the answer, then that is correct. Example 2, suppose you had 2 moles of solute dissolved into 1 liter of solution. What is the molarity? Then we would have 2.00 moles over 1 liter, which is 2.00 with a big M, or molar. Notice there's no mention of a specific substance. The molarity would be the same. It doesn't matter if it's sucrose, sodium chloride, or any other substance. 1 mole of anything contains 6.02 times 10 to the 23 units. And what is the molarity when 0.75 moles is dissolved in 2.5 liters of solution? Our molarity is equal to 0.750 moles over 2.5 liters, so our answer is 0.300 molar. And we can calculate the molarity of a solution when the given amount of solute is in grams. We convert from grams to moles, then proceed as in the previous examples. what is the molarity of a 2.00 solution that has 102.44 grams of sodium chloride dissolved in it? We know with molarity, we're given two numbers in our question, and we never want to start with molarity if it's given, and we always want to start with grams if it's given. We have 102.44 grams of sodium chloride. We need to convert it to moles using our molar mass. So if we look up sodium, it has a molar mass of 22.99, and we add that to 35.45, which is chlorine, and we get a molar mass of 58.44 grams of sodium chloride per mole of sodium chloride. And our grams cancel off, and then we need to convert it to molarity, writing 2.00 liters on the bottom. Remembering that liters does not have a partner to it. Liters by itself, it's not a conversion factor like grams per mole, or like our molar masses or our gas conversion. It is just it's not a conversion factor, it's just another unit, so we need to write it X on the top to remind us there's no partner that goes there. And if we multiply all this out, we have 102.44 divided by 58.44 and divided by 2. And we get 0.876 moles per liter of sodium chloride. Another example here, how many grams of sodium hydroxide are contained in 1.45 liters of a 2.25 molar solution? Remembering we never want to start with molarity, we always want to start with anything but molarity. We start with 1.45 liters, and we convert it to moles using our molarity. Remember that big M means moles over liters. So liters has to go on the bottom. 2.25 moles goes on the top. Liters cancels out. And then we want to convert to grams because our answer is looking for grams. We know when we are looking for grams, we have to find the molar mass. If we add 22.99, which is sodium, plus 16 from oxygen and 1.01, we get a molar mass of 40 grams per mole. Moles cancel out, and we are left with the answer, which is 130.5. 130.5 rounded to proper significant figures, 131 grams. Now, using stoichiometry with solutions, we use the same steps as always. It's just a little bit different. So our first question has how many grams of copper will react to completely replace silver from 208 milliliters of 0.100 molar solution of silver nitrate. Your product will be copper 2 nitrate. This is how many grams of copper will react. We need to write that balanced equation. Copper will react to completely replace silver from silver nitrate. And our product will be copper 2 nitrate. Copper 2 nitrate. And silver. We have to balance that chemical reaction. We have 2, because we have 2 nitrates, we need 2 in front of our silver. Now that we've done that, we need to write our knowns and unknowns. How many grams of copper, that's what we're looking for. And we have 208 milliliters, or 0.208 liters, and 0.100 molarity. Now this sometimes confuses people because we have two numbers under our sodium nitrate, but if you remember from that previous example, we need both those numbers to convert to moles. So we start again with liters, not molarity. If we remember, molarity is moles per liter. We always start with liters and never with molarity. We use that, 0.208 liters of silver nitrate, and we use our molarity to convert to moles. So molarity of silver, we have our liters of silver nitrate and 0.100 moles of silver nitrate. So our liters cancel off. And then it's the same question as any stoichiometry question. We've converted to moles. We just used our molarity instead of molar mass or Avogadro's number. And then since we've converted to moles, we use the molar ratio to convert to moles. We have 0.100 moles of silver nitrate on top. We need to put 2 moles of silver nitrate on the bottom from our coefficient. And then we have 1 mole of copper on the top. We then need to convert back to whatever we want to go, whatever units we would like. Our units that this question is asking for is in grams. Grams means we need to find the molar mass. And if we look up the molar mass of copper, we get 63.55 grams per mole. 63.55 grams of copper goes on the top because we want moles of copper on the bottom. And now we can multiply all the way through. 0.208 times 0.1 times 63.55 is equal to 1.32184 divided by 2 is 0.661 grams of copper. Our next example, what volume of 0.514 molar silver nitrate will be required to precipitate as silver bromide when you have 35 milliliters of 0.150 molar calcium bromide? Again, we start by writing a balanced chemical equation. As what volume of silver nitrate will be required to precipitate as silver bromide when you have calcium bromide. So we're starting with calcium bromide. Calcium bromide. And it precipitates as silver bromide, so it's forming silver bromide. And which means silver nitrate is a reactant, because that one read a little bit funny. It's a little bit complicated, but we can pull it out because we have calcium bromide, and precipitate silver bromide means we produce it. And since we have silver bromide already on our product side, we know silver nitrate needs to go on our reactant side. So we don't have silver on our reactant side yet. And then we need to figure out our other product. We have silver bromide together. We're missing calcium nitrate. We write calcium nitrate as a product. and then we balance. It looks like we have 2 nitrates. We'll need 2 nitrates. And we have 2 bromides. We'll need 2 bromides. And we have 2 silvers. We're good to go. Now we write our knowns and our unknowns. What volume of 0.514 molar silver nitrate? 0.514 molar, which is moles per liter silver nitrate, and we're looking for the volume, which is in liters. And we have 35 mils of calcium bromide. So 35 mils, 0.035 liters of 0.150 moles per liter. And now this might seem confusing, but if we take a look at what we have in our question, we never start with the numbers where there'd be a question mark, excuse me. We wouldn't start with silver nitrate because there's a question mark. We're looking for something under silver nitrate. We need to start with calcium bromide. And we know we never start with molarity in a question. We need to start with the liters. We'll start with 0.035 liters of calcium bromide. And we use that molarity to convert to moles. 0.105 moles of calcium bromide. And the liters goes on the bottom because we need that to cancel off. We've now converted to moles. We need to use our molar ratio. We have calcium bromide on the top, so we'll need 1 mole of calcium bromide on the bottom, and we're looking for silver nitrate. We'll need 2 moles of silver nitrate on the top. Now that we have moles of silver nitrate, we are looking for liters. We have moles on top. We'll need moles on the bottom, 0.514 moles of silver nitrate goes on the bottom, which leaves us with liters of silver nitrate. On the top. Now if we multiply all this out, 0.035 times 0.15 times 2, and we divide that by 0.514, we get 0.0204 liters of silver nitrate. There we go. And one more example here. We have 25 milliliters of potassium of 0.50560 molar potassium chloride are added to copper sulfate. I'm just going to start. We have potassium chloride plus copper 2 sulfate. Nope, copper 2 sulfate. There we go. How many liters of copper 2 chloride will be produced if you start with a 0.620 liter solution? Well, we're missing one product here. We are missing our potassium and our sulfate now. And make sure we write those in as our other product, and then we need to balance. We have 2 potassiums and 2 chlorides, so we simply just need a 2 in front of potassium chloride. And then we write down our knowns and unknowns. We have 25 milliliters, or 0.025 liters of 0.56. That doesn't look like anything. 560 molar. And how many liters of copper 2 chloride will be produced? How many liters if we start with 0.620 liter solution? Oh, I think that's supposed to be a molar solution. I'll have to fix that. in the notes. Molar solution. We don't start with our copper 2 chloride because there's a question mark there. We're going to need to start with our potassium chloride. And we never start with molarity, remembering that molarity is moles over liters. We start with our liters. So 0.025 liters of potassium chloride. And we convert to moles using our molarity. Our liters of potassium chloride go on the bottom, and our 0.560 moles of potassium chloride go on the top. Our liters cancels out. We use our molar ratio. Next, we have moles of potassium chloride on the top. We need 2 moles of potassium chloride on the bottom. And we have 1 mole of copper 2 chloride. Now that our moles of potassium chloride have canceled off, we need to find liters, and we use our molarity in order to find those liters. We moles of copper 2 chloride on the bottom. We'll need moles of copper 2 chloride, moles of copper 2 chloride on the top. We'll need it on the bottom. So 0.620 moles of copper 2 chloride goes on the bottom, and therefore liters of copper 2 chloride goes on the top. If we divide all that out, we get a final answer of 0.0113 liters of copper 2 chloride. There we go.